selamat pagi. Yang berbahagia, Dr. Siti Zulaiha Ahmad, Ketua Pusat Pengajian Fakulti Sains Komputer dan Matematik UiTM Perlis. Yang berusaha, Dr. Nafizah Ibrahim, Koordinator Khusus Sains Komputer, Encik Khairul Azlan bin Abdul Aziz, Koordinator Khusus Sains Matematik. Yang berusaha, Dr. Tajur Rosli Razak, Penyelaras CSP 650. Yang berusaha, Puan Diana Silmayuni Muhammad Nasir, Penyelaras MSP 660, pensyarah-pensyarah dari Jabatan Sains Komputer dan Matematik serta yang diraikan peserta-peserta FSKM Final Year Project Video Showcase 2020. Di kesempatan ini, majlis ingin mengucapkan selamat datang kepada semua hadirin ke FSKM Final Year Project Video Showcase 2020. Walaupun situasi kali ini agak berbeza kerana ini adalah julung kalinya majlis seperti ini diadakan secara maya ataupun online disebabkan wabak COVID-19 yang melanda negara kita. Sama-sama kita berdoa agar wabak ini segera diangkat supaya negara kita pulih kembali. Amin ya rabbal alamin. Seterusnya, bagi memulakan majlis kita pada pagi ini, dengan segala hormatnya mempersilakan Dr. Siti Zulaiha Ahmad, Ketua Pusat Pengajian FSKM UiTM Perlis untuk memberikan sepatah dua kata. Dengan segala hormatnya, dipersilakan.
Okay, Assalamualaikum dan selamat pagi semua. Okay, yang dihormati organizer event kita, FSKM Video Showcase Final Year Project. FSKM, Dr. Tajur Rosli Razak dan Puan Diana Silmayuni dan semua pensyarah serta pelajar FSKM. Okay. Terima kasih ya atas persudian menyertai dan menghadiri program ini yang kita adakan bagi meraih pelajar-pelajar FIP FSKM. Okay, seperti yang kita sedia maklum lah ya, sebelum ni FSKM dia jalankan program REMAX bagi bolehkan semua projek pelajar dibentangkan dan dipertandingkan untuk beberapa kategori. Tapi namun disebabkan masalah COVID-19 dan yang melanda negara kita dan perintah PKP yang dilaksanakan oleh pihak kerajaan, jadi FSKM terpaksa scale down lah sikit event ni kepada virtual showcase sahaja. Apapun, saya ucapkan terima kasih selagi kepada koordinator FIP kita, Dr. Tajur dan Puan Diana atas kesudian menjalankan atau kesanggupan melaksanakan event ni. Semoga insyaAllah tahun depan kita dapat adakan program REMAX ni seperti sedia kala dan sama-sama dapat kita doalah COVID-19 ni terhapus dan dapat diputuskan rantaiannya dan Malaysia kita selamat sejahtera. Jadi tak nak membuang masa, kita saya merasmikanlah majlis ini dengan lafaz Bismillahirrahmanirrahim. Saya serahkan kepada Tuan Pengerusi. Terima kasih.
Terima kasih Dr. Siti Zulaiha atas ucapan yang bermakna sebentar tadi. Hadirin sekalian, bagi tidak membuang masa, majlis seterusnya menjemput Dr. Tajur Rosli, Penyelaras CSP 650 untuk membentangkan laporan berkenaan jumlah peserta Final Year Project bagi program Sains Komputer kali ini. Dengan segala hormatnya, silakan.
Okey, terima kasih saudara pengerusi majlis. Alright, Assalamualaikum dan selamat pagi semua. Okey, yang berbahagia Dr. Siti Zulaiha, KBP FSKM, Dr. Fiza Ibrahim, KK Sains Komputer dan Encik Khairul Azlan, KK Sains Matematik dan rakan-rakan pensyarah semua serta pelajar-pelajar yang diraikan. Okey, so terlebih dulu saya ingin kenali saya Tajur Rosli bin Razak, which is penyelaras untuk CSP 650. Okey, so saya ingin memberi laporan sikit untuk CSP 650 pada semester ni. Okey, untuk pengetahuan semua, semester ni kita untuk final year project kita cuma ada daripada bachelor degree CS 240, iaitu jumlah projek yang kita ada pada semester ni iaitu sebanyak 37 projek, iaitu daripada grup A 19 projek, grup B ada 18 projek. So semua adalah 37 projek sahaja. Jadi saya adalah wakil tunggal daripada FSKM Sains Komputer untuk jadi penyelaras semester ni. Okey. So untuk makluman juga, ini kali pertama saya menjadi penyelaras FYP. Okey, dan tahun ni juga agak mencabar dengan adanya disebabkan COVID-19 ni, sebabnya semuanya kita nak kena online kan. Alright. So di kesempatan ini saya ingin mengucapkan terima kasih kepada semua penyelia yang kerana berjaya menyelia pelajar-pelajar masing-masing dengan jayanya, walaupun kita ada cabaran dengan kena buat semuanya online, masalah internet dan sebagainya. Alhamdulillah kita berjaya, alhamdulillah. So saya juga ingin mengucapkan terima kasih kepada semua panel pemeriksa kerana sudi untuk menjadi pemeriksa kepada pelajar-pelajar. Kerana kali ini kita semua kena selia, kena memeriksa melalui online, kita guna soft copy report dan juga video. So itu sebabnya hari ini kita sedikit nak memberi penghargaan pada sebab semuanya kita kena buat video semester ni. So that's why adalah sedikit penghargaan kepada video-video yang terpilih nanti. Sebenarnya semua video-video adalah yang terbaik, cuma kita ada kekangan, kita cuma boleh pilih top 3. Alright. So disebabkan video-video ni juga penting sebab saya rasa selepas ni banyak juga innovation di luar tu yang memerlukan kita buat video. So since kita dah ada semua ni, maklumat-maklumat ni, so mungkin kita boleh bawa lebih lah projek-projek pelajar kita masuk ke innovation. Alright, so akhir kata daripada saya, sekali lagi saya ingin mengucapkan syabas kepada semua pelajar tahun akhir, kepada sains komputer pelajar dan juga sains matematik. So all the best, terima kasih semua. Itu sahaja daripada saya. So over to you, Tuan Pengerusi Majlis.
Terima kasih Dr. Dajjal atas pembentangan laporan sebentar tadi. Majlis akan diteruskan lagi dengan mempersilakan pula Puan Diana Sirimayuni, penyelaras MSP 660 untuk membentangkan laporan berkenaan jumlah peserta FYP bagi program sains matematik kali ini. Dipersilakan.
Okey, terima kasih kepada pengerusi majlis, KPP, para pensyarah dan para pelajar yang diraikan. Okey, untuk pengetahuan semua, pada semester ni pelajar seramai 88 orang pelajar telah mendaftar untuk kursus MSP 660 dan projek yang kita telah terima dan telah disiapkan tepat pada masanya adalah sebanyak 86 projek. So saja di kesempatan ini saya ingin ucapkan terima kasih dan syabas kepada semua pelajar yang telah dapat menyiapkan projek dengan jayanya. Okey, so untuk pengetahuan semua, pemilihan top 3 untuk setiap program telah dipilih berdasarkan penilaian yang telah dibuat oleh examiner dan panel. Kalau untuk MSP 660, panel dan examiner akan mengisi ada borang yang telah disediakan dan borang penilaian tu ada satu kolom iaitu recommendation for best video. So pemilihan dibuat berdasarkan jika the answer is yes from both panels and examiner. So kita akan, and then the next step kita pilih untuk berdasarkan pada the highest mark lah, markah yang tertinggi. So suka saya ingatkan di sini penilaian dibuat berdasarkan hanya untuk video presentation. So tidak hanya untuk video presentation sahaja dan tidak termasuk penilaian untuk laporan FYP. So video ini dipilih berdasarkan creativity, style appearance and etc. lah, termasuk sekali visual acts. So untuk akhir kata, saya ingin ucapkan ribuan terima kasih kepada semua panel, kepada semua pensyarah yang telah bertungkus lumus memberi komen, membuat penilaian untuk video dan juga laporan FYP dengan kekangan yang pelbagai yang kita hadapi. Okey, tapi kita dapat siapkan ataupun kita boleh dapat buat penilaian secara sangat apa kita panggil successful. Okey, so terima kasih di atas komen-komen yang membina daripada semua panel. Dengan semoga dengan usaha dan segala ilmu yang telah disampaikan, segala pandangan positif, feedback daripada semua panel kepada pelajar, semoga dapat kita jadi sebagai macam saham akhirat kita lah, sebab hanya Allah yang dapat membalasnya. Okay, so itu saja untuk daripada saya. Sekali lagi diucapkan terima kasih pada semua. Okay, balik pada pengerusi majlis.
Terima kasih Puan Diana atas pembentangan laporan sebentar tadi. Hadirin sekalian, kini tibalah masa yang dinantikan, iaitu pengumuman 3 tempat terbaik bagi FSKM FYP Video Showcase 2020 kali ini. Pengumuman akan dimulakan bagi program CSP 650 terlebih dahulu. Tempat ketiga jatuh kepada Muhammad Amir Aufa bin Muhammad Abdillah dengan projek bertajuk Designing Echo Feedback of Gas Emission Detection and Notification via SMS. Muhammad Amir disediakan oleh Puan Romiza untuk projek kali ini. Beliau akan menerima wang tunai sebanyak RM70 sebagai hadiah. Tahniah diucapkan. Seterusnya, tempat kedua jatuh kepada Muhammad Amirul Rashad bin Muhammad Halim dengan projek bertajuk IoT-based Smart Garbage Monitoring System using Arduino and Blink. Muhammad Amirul disediakan oleh Cik Siti Sarah Mat Ilyas untuk projek kali ini. Beliau akan menerima wang tunai sebanyak RM75 sebagai hadiah. Tahniah diucapkan. Dan tempat pertama, FSKM Final Year Project Video Showcase 2020 disandang oleh Nur Humaira binti Muhammad Yusof dengan projek bertajuk Harum Manis Mango Leaf Disease Detection System using Image Processing Technique. Nur Humaira disediakan oleh Profesor Madya, TS Dr. Syukur Sania berserta Encik Ray Adeli untuk projek kali ini. Beliau akan menerima wang tunai sebanyak RM100 sebagai hadiah. Tahniah diucapkan. Baiklah, majlis akan diteruskan pula dengan pengumuman 3 tempat terbaik FSKM Final Year Project Video Showcase 2020 bagi program MSP 660. Dan tempat ketiga jatuh kepada Maizatul Akmal binti Jafridin dengan projek bertajuk Comparison of Fuzzy Time Series and Arima on Forecasting Tourist Arrival at Homestay in Pahang. Maizatul disediakan oleh Puan Rohana Alias untuk projek Profesor Madya Rohana Alias untuk projek kali ini. Beliau akan menerima wang tunai sebanyak RM70 sebagai hadiah. Tahniah diucapkan. Seterusnya, tempat kedua jatuh kepada Nur Hayati binti Muhammad Aziri dengan projek bertajuk Solving the Travelling Salesman Problem by Using Artificial Bee Colony Algorithm. Nur Ainul disediakan oleh Profesor Madya Siti Hafawati Jamaluddin untuk projek kali ini. Beliau akan menerima wang tunai sebanyak RM75 sebagai hadiah. Tahniah diucapkan. Dan tempat pertama FSKM Final Year Project Showcase 2020 bagi program MSP 660 disandang oleh Siti Aisyah binti Ismail dengan projek bertajuk Predicting Heart Disease Using Ant Colony Optimization. Siti Aisyah disediakan oleh Dr. Rizauddin Sayan untuk projek kali ini. Beliau akan menerima wang tunai sebanyak RM100 sebagai hadiah. Tahniah diucapkan. Hadirin sekalian, sebelum kita mengakhiri program kita pada hari ini, marilah sama kita saksikan tayangan video tempat pertama FSKM Final Year Project Video Showcase 2020 bagi kedua-dua program.
Assalamualaikum. I'm your Assalamualaikum. Assalamualaikum. I'm Humaira Muhammad Yusuf, and right now Assalamualaikum. I'm Humaira Muhammad Yusuf, and right now I'll be presenting my final year project, which is Harumanis Mango Leaf Disease Detection System using image processing technique. Mango is one of the most important food crops cultivated in Malaysian agriculture. Its demand has also been increasing annually, thus it is vital for farmers to keep an eye on the condition of the mango tree health, as it plays a huge role in producing healthy mango fruits. Traditionally, the farmers carry out a visual inspection by comparing the amount of greenness of the leaves. They use their naked eyes to detect the potential diseases. However, this approach seems to be less efficient, and here's why. First off, it consumes more time, and farmers may overlook some leaves that are already impacted, as well as missing the right time to prevent and treat them. In addition, this approach is also not applicable to everyone, as farmers hugely rely on their human expertise. Most of the reported works on smart farming were conducted on crops such as rice and tomato, whereas very little on the Harumanis mangoes. The previous solutions also mostly only covered on fruits rather than leaves. Therefore, this project aims to develop a mango leaf disease detection system to assist farmers in producing a better yield of Harumanis mango. Here are the research objectives. The first one is to identify the requirements and suitable technique to detect the Harumanis mango leaf disease. Next is to develop a Harumanis mango leaf disease detection system by using image processing technique. The final research objective is to evaluate the system through the performance evaluation. The tool needed for this project is a smartphone, which will be used to get the digital image of the mango leaf. The Harumanis mango leaf diseases that will be detected by the system are anthracnose and bacterial black spot, as they are the diseases that are mostly found at the Harumanis mango crop selected. This project will be developed for UIP Antonis Mango Farm, as this place is one of the producers of Harumanis mango. Now, by implementing the approach of this project, farmers can produce better quality of mango to satisfy the consumer's demand, which will contribute to greater profits. Moreover, as farmers tend to use pesticides to avoid a disease outbreak and pest growth, the project can reduce the use of hazardous pesticides that pose a major threat to human health. This project will help in promoting smart farming among both smaller scale and bigger scale farmers, as it is still a field with a lot of potentials in Malaysia. A literature review was conducted, and from here, it is known that smart farming is generally about capturing, storing, and analyzing real-time data and automation technology on farming procedures, which opens the door to improvement of overall farming operations and management. They are tropical fruits that have valuable commodity for the agricultural sector in Malaysia, and one of them is mango. Mango is a tropical fruit that belongs morphologically to the Gillis green fruit subtype and possesses one large seed, which is surrounded by fleshy mesocarp. Mango has a lot of varieties, and Harumanis is one of the examples. In Malaysia, Harumanis mango is so popular that it is crowned as the king of mangoes due to its deliciousness as well as its unforgettable sweet taste and aromatic smell. Here are some of the major mango leaf diseases. First one is anthracnose, which is a severe fungal cyst and leaf fungus. Small black or dark brown spots are the first symptoms on panicles, which is usually the indicator for the farmers to detect this disease. The fungus Alcinium mangiferae is the cause of mango scab, in which its infection can be severe and lead to defoliation of new shoots. Small black spots develop newly set fruit, and the fruit falls off when it is infected by multiple black lesions. Next is the bacterium black spot, which is capable of attacking leaves, branches, and fruit. Infection is favored with intermittent rain due to warm, humid condition. And finally, the fungus oidium, which causes powdery mildew and also causes severe crop loss. The critical key to distinguishing this disease is the presence on panicles and young fruit of the whitish powdery growth of the fungus. There are a few techniques to detect plant diseases, which includes molecular technique and hyperspectral technique. Some of the drawbacks of these techniques are that they are time-consuming and labor-intensive and require an elaborate process, especially during sample preparation, in order to obtain reliable and accurate results on the identification of plant disability. The other disease detection is image processing technique, which minimizes the subjectivity of traditional classification methods and mistakes committed by human beings. The approach is also simple, in which it only needs computers, digital cameras, as well as the software programs that are necessary. Considering all the advantages of image processing, the proposed system will therefore detect the Haromanius mango diseases by implementing the image processing technique. Now, as mentioned, this project implements the image processing technique. The basic step for this technique includes image acquisition, image pre-processing, feature extraction, segmentation, detection, and classification of plant disease. The software that will be used is MATLAB. The image processing toolbox will be used to develop the project, while the graphic user interface will be developed using MATLAB's guide. The hardware that will be used to develop the project are a smartphone with a high-resolution camera and a laptop. Here's the overview of the methodology of this project. The first phase is project initiation. The subtasks that are involved in this phase are identifying the project requirements, as well as identifying the suitable technique. Both of these subtasks are identified by reviewing a series of previous related works. Thus, the expected deliverables from this phase are the requirements and technique being identified. The second phase is design and development. For system visualization, Microsoft Visio will be used to develop a figure sketch that illustrates the general flow of the system. For image acquisition, the images of different leaves are captured using a high-resolution camera, and these images will then be divided into training image and testing images. For image pre-processing, various pre-processing techniques can be taken into account to eliminate the noise from the image. For instance, image enhancement is done to increase the contrast. Next is image segmentation. Image segmentation is the method by which an image is portrayed into something more significant and easier to analyze. For this project, the image will be segmented where RGB picture is then transformed into HSI. For feature extraction, color, texture, and morphology can be considered as a feature for disease detection. The gray level co-occurrence matrix, GLCM, is used for this project. Features like contrast, correlation, energy, and homogeneity can be extracted from GLCM. For disease classification, the leaves will then be classified into three classes, which are healthy leaf, infected by anthracnose, and lastly infected by bacterial black spot. Once classified, the results can be obtained. The final phase of the methodology proposed includes evaluating the prototype by testing the system performance. The test will be carried out through a performance evaluation. This will be done by using the confusion matrix table. Next, the calculations to get its accuracy, recall, precision, and F1 score will be performed. It is possible to obtain the accuracy rate of the system through this task. Now I will demonstrate the system, demonstrating the Haromanius mango leaf disease detection system. And first off, I'll show how to train the leaf images first. So as I mentioned, the first step of image processing technique is to acquire the image. So an image needs to be selected first. once the image is acquired, the system will perform the other process such as image pre-processing and image segmentation, and then the feature will be extracted. After that, we need to enter the class of the disease. Class 0 indicates that the leaf is healthy. Class 1 indicates that the leaf is infected by anthracnose, while class 2 indicates that the leaf is infected by bacterial black spot. So in this case, it's 1 because it is infected by anthracnose. Now, once the class is entered, all of the data will be stored in this database called dd.map. So I'll show you one more example of training the leaf images. In this case, it's class 0 because it is healthy. Now I will show you the user interface of the system, or basically the testing phase of the program. So here's the user interface. First, just like the training, we need to acquire the image. And then the image will be pre-processed, in which the contrast is enhanced, and the image will be segmented, in which the image will be converted to HSI image. Then you can click on the results, and here it says that the leaf is infected by anthracnose. So I'll show another example. The results, and the leaf is healthy this time. So I think that is all for the demonstration. Now we're back to here. So here's the results and finding. The main objective of the project, as mentioned before, is to test the performance of the system. This table here depicts the comparison between the proposed approach and the other two existing systems, as well as the accuracy rate of these three systems. The overall accuracy of the proposed system is 68.89%. It can be seen that the proposed system had the lowest accuracy rate. This may be due to the fact that the proposed system lacked training images. Next, both existing systems also use SVM classifier, which will give more accurate results, especially when more images were trained. The proposed system also only extracted the texture feature, thus this might contribute to the percentage of overall accuracy. To conclude, through this project, farmers can produce better quality of mango to satisfy the consumer's demand, reduces the use of hazardous pesticides that pose a major threat to human health, as well as help eliminating the need of having expertise in detecting the Haromanious mango diseases. While developing and testing the project, there are a few problems and limitations encountered. The first one is less training images, as acquiring the Haromanious mango images were quite impossible due to the current situation, which is COVID-19 outbreak. Next is less features statistical were included in the feature extraction process due to coding error. The results of the disease identification were also inconsistent at times, which also affect the accuracy rate of the system. There are several elements of the prototype that can be improved or enhanced. For instance, improve the performance of the system by adding additional IoT sensors. Next, develop a mobile application to convey the information about the disease to the farmers in their local languages so that the user friendliness of this system can be improved. Additionally, the system can also be improved by using a better classification technique, such as using an SDM classifier and k-mean clustering algorithm during image segmentation for more accurate result. That is all from me. Thank you very much.
Baiklah. Kita teruskan pula dengan tempat pertama untuk MSP 660.
Let's talk about heart disease. Did you know that heart disease is the leading cause of death in many regions of the world, including Malaysia? Be it a big three like Russia, US, China, or maybe small country like Japan, Indonesia, or Thailand, heart disease also has been the major cause of death among them. If you don't know about this fact, you better be alert about it. According to the Deputy Minister of Health, Dr. Lee Bonche, heart disease, are also known as cardiovascular disease, has remained as the main cause of death among Malaysians between 2005 and 2017. It has increased significantly by 54% over the last 10 years, and Malaysia has ranked on number 64 in the world. Sounds serious, right? But today, I am not going to talk about heart disease in details, as I am not an expert in mental health. Instead, I am going to explain about my pioneering project, which has been triggered by heart disease issue entitled Untitled Heart Disease and Chronic Optimization. The significance of this study is the ability to predict the heart disease using the patient's health data. Early prediction can provide awareness and also preparation for the doctors and the patients themselves. The objective of this study is to create a classification model by pre-processing the heart disease dataset, training the heart disease dataset using chronic optimization algorithm, and validating the classification model. I have used a heart disease dataset from UCI Machine Learning Repository that contains information from 4 institutions. So, how am I going to use this dataset to predict the heart disease? The answer is by using n-colony optimization together with data mining to create a classification model, which is called as n-miner. Let me first explain about n-colony optimization and data mining. N-colony optimization, or also known as ACO, is a system based on the behavior of real ant colonies in nature. Ants, in search of food, release chemicals called pheromones that may be detected by other ants. Ants mark the path to walk by using pheromones as food forage clues for other ants. When the time and number of foraging ants increase, pheromone intensity in the atmosphere may change, leading between their nest and the food. Meanwhile, data mining involves analyzing database for patterns and trends in large datasets. The overall goal is to extract knowledge from an existing dataset and transform into a human understandable structure. The classification task in data mining and decision making consists in associating a case to a class based on cases attributes. Based on SEO and data mining, the previous researchers Papinelli, Lopez, and Freitas has proposed the n-miner algorithm in 2002. Hence, I have used n-miner to create a classification rule to predict the heart disease. As we know, patients' health data have a lot of information, such as their blood pressure, their cholesterol level, their sugar level, and so on. So, with this health problem of the patients, the doctors are facing difficulties to point out the existence of heart disease. Hence, the classification model is needed in this time. This method will use some formulas to come out with classification rules such as the entropy, the heuristic, and lastly, the probabilities. The terms with higher heuristic value is most likely to be chosen, and the terms with the highest probability value will be added to the row. This table shows the percentage of accuracy at different number of n's, which is starting from 100 to 400. The higher the accuracy value, the better the classification model. We can see that the highest accuracy value is 78.85% at the number of n's equal to 300. I have run the heart disease dataset into a software which is called as GUI and Miner. The GUI and Miner has produced the accuracy result just now. So after that, I have to compare the percentage of accuracy with another method, which is J48 in Weka software tools. The accuracy result from J48 is 73.93%, which is lower than N-. Here we can see that N- give a better predictive accuracy compared to J48. This table shows the attributes that are in heart disease datasets. We have age, sex, chest pain type, rest blood pressure, serum cholesterol, fasting blood sugar, resting electrocardiographic, maximum heart rate, exercise-induced angina, oil peak, slope, number of major vessel, defect types, and lastly the class. The class here represents the absence and presence of heart disease of the patient. Now, let's take a look at the result of N-. Before I run my heart disease dataset, I have set the cross-fold validation to 10, the number of n's equal to 200, minimum cases per rule equals to 5, maximum uncovered cases equal to 10, rules for convergence equal to 10, and number of iterations equal to 100. For the first cross-validation, the cases in the training set is equal to 272, while cases in the test set is 31, and the rules generated here is equal to 6. In the first cross-fold validation, as we can see, if exam or exercise-induced angina is equal to 0, or CA or number of major vessels is equal to 0, then the class is 0, where the class here represents the absence of heart disease. And there is 6 result of rules in the first cross validation. And the next second cross validation, third cross validation, there are several rules generated and the result is different until the 10th cross validation. And the last one, this is the result of accuracy, where the highest accuracy of the best is 78.85%, and with the rules number of 5.9 and conditions number is 7.4. In conclusion, heart disease can be predicted by using N- algorithm. In the future, I was hoping that the model of this study can be used to build an application that can predict heart disease that can be used not only by health experts but also by other people, where the application will keep health on track. That's all for me. Thank you for being with me here today.
Baiklah, tahniah sekali lagi diucapkan kepada kedua-dua pemenang. Hadirin sekalian, sebelum program ini melabuhkan tirainya, diharapkan semua peserta dapat mengisi kehadiran pada link yang disediakan pada ruangan checkbox di bawah. Jadi, dengan berakhirnya tayangan video itu sebentar tadi, maka tak makna sudah program FSKM FYP Video Showcase 2020 yang diadakan secara maya buat julung kalinya. Sekali lagi tahniah buat para pemenang dan semoga projek yang kalian cetuskan ini akan dapat membantu semua masyarakat kelak. Maka dengan itu, majlis mengucapkan ribuan terima kasih kepada semua hadirin atas kesudian dalam penglibatan sepanjang program ini berlangsung. Sekian, wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi taala wabarakatuh.
Okay, tahniah semua. Terima kasih.